In this video, we are solving a pair of simultaneous linear equations, and we want them to be in this form. The x terms align, the y terms align, and the constants align. But that's not the case, and simply because of equation 2 for these two equations. We see we have 2y equal x minus 5. So what we really need to have them in this form over here is to take this x term and transpose it to the other side. So we want to have it on the left-hand side. So we have the x's aligned now. But once we transpose a term from one side to the next, over here it was positive x minus 5. So once we transpose over the equal sign, it moved from being positive on the right to what? Negative on the left. So we need to ensure we put a negative sign in front of the x there. Now we need to separate these two terms. So the 2y is positive, so we'll just use a plus in front of it. So we have negative x plus 2y equals negative 5. Now let's get this minus or negative 5 a little closer to the equal sign. Now notice that I did not transpose the negative 5 from the right hand side. We just shifted closer to the equal sign. So it's still on the right hand side. So the sign will not change. Okay, so now we have them aligned. Here's what we'll do. Let's get rid of the x terms. Now what's the LCM? Now mind you, this is actually negative 1x. So what's the LCM of 4 and 1? Excellent. That's correct. The answer is 4. The LCM of 4 and 1 is actually 4. So we will simply need to multiply the second equation by 4. Okay. And the first equation, if we say we want to multiply it, no problem. It's already 4, so we can just say we multiply by 1. But technically, multiplying by 1 do not change the equation. So we're going to write back the top equation, which is equation 1, which is 4x plus 3y equals 31. Now we're going to multiply 4 by each term in the second equation. So 4 times negative x is negative 4x, and 4 times positive 2y is positive 8y, and 4 times negative 5 is negative 20. Now you may wonder why I did not multiply by a negative number. Well, that's because when we inspect the original terms, the x terms of the two equations given to us, they already have different signs. And so to eliminate, remember what we want. We want them to have what? Same size, then what? Different signs. And once they have the same size and different signs, we proceed to add both equations. Okay, so here we have the x terms. Let's pay attention to these two equations down here. So this is equation 1. This is equation 3 derived from equation 2. So we're only focusing on equation 1 and 3 at the moment. So here we have both equations. Remember the rule to eliminate. They must have the same size, and they do, and they must have different signs. This is positive 4x and this is negative 4x. So what's the rule? When we add in both equations, notice that for the like terms, if they have the same signs, what do? We add and keep the sign. So we'll keep positive. And if they're both negatives, again, we also add and keep, but in this case, we keep negative. But if they have opposite signs, we will need to do what? Subtract. And we keep the sign of the one that is bigger. So these two have opposite signs, and the rule is that we subtract. So subtracting 4 from 4 give us 0. So those are cancelled out. Look at 3y and 8y. Well, we see that they have the same signs. And if they have the same sign, we add and keep the sign. So that will be 11y equal. Now if we look at 31 and negative 20, they have opposite signs, different signs. And if they have different signs, again, we need to subtract. So what we do, we take the smaller number from the larger number. That will give us 11. And which sign do we keep? Since we have more positives than we do negatives, our answer will be a positive. More positive than negative, our answer will be a positive. Now we need to find the value of y. Well, we inspect the number that is right before the y term, and that's 11. So we will divide by 11. Remember, a coefficient multiplies the variable. So to get rid of it or to unattach it, we need to divide, the reverse of multiplication. So dividing 11 into 11 give us 1. And so that's what we want. We want to have 1y. We typically don't want write the 1 before the y. 11 goes into 11. Every number goes into itself once. So the answer there is positive 1. So y is equal to positive 1. So we're going to substitute y into, let's check the original equations. We have 4x plus 3y equals 31. That's a good one for us to use. 4x plus 3y equals 31. So this is equation 1. And we're going to substitute the value of y in it. So we have 4x plus 3 times the value of y. And we use bracket to indicate this equals 31. And but 3y means 3 times y. And replace y with the value that we found earlier. And so we're going to simplify this line. Let's simplify that line. 4x plus 3 ones 3 equals 31. Let's move down to the next line. What we need to do here, we need to subtract the 3 because it's a plus 3. So we need to unattach it by subtraction. We need to subtract 3 from both sides. And so we end up with, let's write back the 4x. And this will cancel this. Equal. Now 31 minus 3 will be 28. Now to get the value of x, we need to divide by the coefficient of x. And the coefficient of x here is positive 4. Coefficient multiplies, so we will get rid of it by division, the reverse. And dividing these two, what will we end up with? 4 goes into 4 once. So we have 1x. And 4 goes into 28 7 times. And so this is our solution. X equals 7 and y equals 1.